This is what I'm calling the Ouija board. Stick around to see how I built it, how it works, and how you can get your hands on one. But first, let's rewind to where all this began. The entire idea for this came from an offhand kind of throwaway comment. Because of who I am and how my brain is wired, I couldn't just leave it as a hypothetical. Once an idea like this hijacks my brain, I have to make it a reality. And of course, this conversation happened about a month before Halloween, which is just enough time to make it happen. For someone like me with ADHD, that's a perfect amount of pressure to get things done. My therapist calls this an adrenal response, and that is not healthy. But hey, they don't have a Ouija board that talks to ghosts, so who's really in the wrong here? Nothing says focus quite like an approaching deadline. With only 4 weeks until Halloween, the clock was already ticking. I started by laying the foundation, getting the basic concept down on paper, and breaking the project into its core components: mechanical design, software, and electronics. This is where I put my mechanical design skills to work. The first thought was a simple Cartesian system using servos to control the X and Y axes. It seemed straightforward enough. 2 motors, one controlling the horizontal movement and the other the vertical. With the basic concept in place, it was time to dive deeper into the mechanical design. I wanted this to be as thin as possible, nothing that would give away the trick. I could have just slapped the planchette onto a laser cutter, but that would have been a dead giveaway. My idea was to use pulleys and bearings, much like an Etch-a-Sketch, to move a magnet onto the board, which would then move the planchette. This is where the mechanical design started getting tricky. I needed ball bearings for every bend in the string because of something called the capstan equation. Too much friction and the servos stall out. Now, bearings sidestep this entire issue, but I need a lot of them and they do cost money. By the end of the second week, I had a finished CAD model, but the design was far from perfect. It was thin and looked good, but the complexity was already creeping into the project. Now, with the mechanical design taking shape, it was time to tackle the software and electronics. I wanted the Ouija board to be as user-friendly as possible. No sketchy apps, no complicated setups, and for this I chose the ESP32 for its built-in Wi-Fi capabilities and started writing the code to control the servos. Setting up the ESP32 to create the Wi-Fi network was pretty straightforward, but the real challenge was the interface. I needed to create a custom web page that users could access on their phones to control the board. I dove into HTML, CSS, and JavaScript, building a simple interface with buttons that would send commands to the ESP32. With only a week left until Halloween, the pressure was really on at this point. This design had multiple 20-hour prints, 16 bearings, tons of wire, glue, custom fit 3D printed parts, and that's all before I can put it together to see if it actually works. The servos were powerful, but that meant they drew a lot of current. As I started wiring everything together, I noticed that the ESP32 would occasionally brown out. I tried adding capacitors to smooth out the power supply, but the problem persisted. By the end of week 1, I was running on fumes. The board was functional, but just barely. The mechanical system was holding up, but only after countless adjustments. The software was usable, but not the seamless experience I'd envisioned. So I missed the Halloween party. The Ouija board just wasn't ready in time, but that turned out to be a blessing in disguise. It gave me a chance to rethink, redesign, and create something I think is way better. Now, with the pressure off, and after a little mental health break from the project, it was time to jump back in. First step is a postmortem. The Etch-a-Sketch design was crazy. Just way too many bearings. Building an entire box with a 3D printed part is just too much printing. So I started from scratch with a new approach, a 5-bar linkage system. It's mechanically simpler, it's more elegant, and it's easier to build. Essentially, I'm taking the time-honored tradition of taking a mechanical problem and making it a software problem. The 5-bar linkage system allows for more precise control, the trade-off being a 5-bar linkage is a non-linear system. This essentially means I need to do some math to connect the XY final positions with the corresponding motor angles. This is called inverse kinematics. To solve the electrical brownout issue, I built a custom circuit board and switched over to steppers. They're more precise, way more power efficient, and not that much harder to control. Now, to use it, you open it up and plug in the battery. The steppers do a little homing routine, and the ESP32 creates a Wi-Fi network. Connect to that network, open the web page, and you're ready to go. Press a button, the board does the math, and the planchette moves, just like magic. So if you're interested in freaking out your friends this Halloween, or you're just into cool tech projects, check out the link below to my website. I'm selling a limited quantity of finished boards, but if you're more of the DIY type, I've got plans and videos to guide you through making your own. Thanks for sticking around to the end. Don't be a stranger in the comment section, and I'll see you in the next one. Bye. This is the Ouija board. It's a thing. Please buy it. I don't know.